Okay, so let's take a look at this. So what did you do first here? What did you do with this negative 4 power here? Yeah, you kind of distributed it in so it goes to the 3 places. So I agree with 2 to the negative 4th. Hold on a sec, Alt is being pressed. I guess x to the negative 4th and y to the 8th. Good. And then it is 2 to the 1st. That's the invisible power. X to the 4th stays. Oh, good. Excellent. So then what did you do? You combine the terms, a few of them, things with the same base, x to the negative 4 and x to the 4. And those two came out and turned into x to the 0. We like that. And then you have y to the 8th and y to the negative 3. So those combine to turn into y to the 5th. Good. I like that. And then what is x to the 0? What's x to 1? It's just invisible now, right? On the bottom, what'd you do? Did some canceling, I think. Yeah, you cancel that y to the 3rd with that y to the 5th, leaving you with just the 2nd. I like this. And then this goes down below. Y squared over 2 to the 4th x. Cool. One other thing you could do, 2 to the 4th is small enough for you to say, what is 2 to the 4th? No. Yeah. So it's 16x squared. That's fine. Either one would be fine.
Why is it 2 to the 4th?
Because it was 2 to the negative 4th on top, so it becomes 2 to the 4th. Oh.
Wait,
What? Okay, kids. Kids, we'll go back. Listen. Look, there's a 2 already down there, right? So she had, what do you see right there? 2 to the negative 3 over 2 to the 1st. That's 2 to the negative 3 minus 1, which is 2 to the negative 4, which is the same thing as 1 over 2 to the 4. So that's why there's a 2 to the 4th in the bottom there. So that's absolutely correct. Good job. I like that. Excellent. Okay, let's see how it went here. So I like what you did there. First you distributed that negative 2 power in, right there and right there. So you got 2. I agree with that and that. And then on the bottom, you just left it the way it was, right? You just left it out how it was. So what? Oh, you can't. There was a y to the negative 2 on the bottom. Canceled that out. And then you started combining like terms, I'd imagine. I like that. Oh, I like how you cleaned it up first. That's great. Just clean it up. And what do you end up with? Negative 3 and 4 is going to be negative. Well, what should that be? Where's the x? Oh, at the way end. I see. Ah, thank you. So it's negative. Oh, good. Negative 1, good. And then y to the 3rd. Excellent. This is all good. And that's 1 over 2 squared, so it's 1/4 times x over. This is excellent. Totally correct. Awesome. That's great. Good job. Okay, so what do we do with that negative 1 power? Where does it go? To everything. Exactly. Not just the top. You also have to distribute it to the, so there and all the other places down there, right? So what does it become? X to the negative 2, y to the over 2 to the, and what, okay, we can do this, y to the x to the negative, y to the negative 1, x to the squared. Good. So before you start subtracting powers, what could you do to the bottom? Combine stuff on the bottom first. Do it in steps. One of the easiest ways to get these wrongs is do too many things at once. So it's 2 to the negative 1, y to the what? X to the what? X to the negative 2. Is that correct? Now what automatically cancels? Yeah, these are gone, right? So you're left with y. That's a terrible y. Y to the negative 4th over 2 to the negative 1. Good. So what does that become? Where does that 2 to the negative 1st go? It just becomes 2 over y to the 4th times y to the negative 2. I just dropped this one down below. And what is I'm taking it too many steps. So what did the power on the bottom become? Y what? So 2 over y squared. Good? Yay? Okay, so again, what should we do first? Distribute all the different powers, right? Just keep track of them. So you end up with 2 cubed v to the u to the 9 times 2 u to the negative 6. U and v are bad. You know, I don't know why m and n are paired together, or u and v, considering they look so similar, especially when I write them. And what does the bottom become? 2 to the u to the v to the. So are there automatically something you can cancel? Just kill those immediately, right? Now let's clean up the top. What does the top become? 2 squared is still up there, right? V to the, so we took care of that. V to the what power? V to the negative 5, because you have 3 and negative 8. And then u to the negative 15 all over u to the v to the. So now you just have to be careful to pair up everything correctly. There are your v's right there. So it turns out to be 4 on top, right? What's negative 5 minus negative 12? Nope. Negative 5 minus negative 12? No. Negative 5 minus negative 12 is what? 7. Because it's negative 5 plus 12, right? So those go away right there. And then what's negative 15 minus negative 24? That's not quite done yet because we have the negative exponent in there. We don't like it. So what do we turn that into? 4v to the 7th over what? Yeah, there you go. Be very careful. Zoe, it says, again, it's m and n again. I don't like it, but a to the m over a to the n is a to the m minus n. This is all over 1. So you can think of it as that a to the n is coming to the top, but you have to subtract it. Any number, like what's 5? 5 over 1. So, you know, what does this mean? What does that mean? The square root of x, right? Square root of x. You agree to that? Okay. So the question is, the square root of x is x to what power? That's the question we're going to answer. The square root of x. So I'm not asking you to guess. This is what we're going to figure out. This is what we're going to figure out. The square root of x is x to some power. Let's see if we can figure out what it is. How do you get rid? I'm not asking you to guess. I'm not asking you to guess, so please don't guess. How do you get rid of a square root? Like if you want to get rid of a square root, what do you do to both sides? Well, what can you do to both sides to get rid of a square root? Multiply by what? Itself. So let's multiply both sides by itself. So you can square both sides, right? If a equals b, does a squared equal b squared? If a equals b, does a squared equal b squared? Yes, it does. If two things are equal, if you square both sides, it's still true. So if we square both sides, what is the square root of x squared? What does this become on the left? It's just x, exactly. The square root of 3 times the square root of 3 is what? 3. The square root of 5 times the square root of 5 is 5. The square root of 7 times the square root of 7 is 7. The square root of a pony times the square root of a pony is a pony. If you square root something and multiply it by itself, what are you left with? Itself. Does that make sense? Now, what do you do here? What do you do with powers of powers? You know what you do with powers of powers. We just looked at that. You multiply. So it's going to be x to the what power? 2 times what? 2 times question mark. So this is, we can do this. This is still true. Still true. It's the same relation. What's the power of x over here? What's the power on the left? 1. The invisible power is 1. So we know that x to the first equals x to the 2 times question mark. If x to the first equals x to the 2 times question mark, what has to be true? If x to the first equals x to the 2 times question mark, what has to be true? 1 has to equal what? If x, this is the same x on both sides, if x to the first equals x to the 2 times question mark, what does 1 have to equal? 2 times the question mark. If x to the first equals x to the 2 times question mark, 1 has to equal what? 2 times question mark. Does that make sense? Are you following what's going on? If x, it's the same thing on both sides, but the powers are different, but for things to be equal, the power have to be the same. So 1 has to, oh, okay, what can we divide both sides by? 2. So what does question mark equal? 1/2. So we just showed everybody the square root of x is equal to x to the 1/2. What do you think the cube root of x is equal to? Take a guess. What do you think the cube root of x is equal to? Take a wild guess. X to the 1/3. Exactly. What does the 7th root of x equal? Exactly. So there's actually an invisible number here. Do you know what the invisible number is there? 2. It's actually 2, square root. It's 2. So that's where it comes from. So if I said you had the nth root of x, what's the nth root of x going to be? X to the 1 over n. So there's your first rule right there for fractional exponents. So for example, let's say I said this, the 5th root of x to the 20th, y to the 35th. What does 5th root mean? 1/5 power. What do you do with powers of powers? What do you do with that 1/5 now? So you get x to the 20 over 5 times y to the 35 over, what's 20 over 5? 4. So it's x to the 4th, y to the 7th. Done. You just simplified an expression with fractional exponents. There's one other thing I want to add in to make it a little bit more general. So you remember, we just did this. The nth root of a is equal to a to the what? 1 over 7. Do you agree with that? So what happens if I did this? What happens if it was the nth root of a to the m power? Well, that's going to be a to the m to the what power? 1 over n, right? We haven't changed anything. We just replaced a with a to the m, right? What do you do with powers of powers? You already know this. You multiply, so it turns into a to the m over n. So what do you know? The nth root of a to the m power is equal to a to the m over n. So that's the super general way of doing it. What we're going to try is see if you can actually use this rule. We're going to put it up on the board, and we're going to see where you can use this in simplifying exponential expressions, because are all exponents going to be whole numbers or negative? No, sometimes they're going to be fractions. This also goes backwards. So let's say I said this. What is 9 to the 1/3? What does that mean? That means cube root of 9. So what happens if I said 6 to the 1/7? What does that mean? 7th root of 6. So what happens if I said this? 5 to the 3/4. That's some root of 5 to some power. 5 to the 3rd, and what root is it? 4th root. So they go both ways. These rules go both ways. Yes, it's a lot to take in. I'll leave this up here. Do you have the same base on a? 4 and 4, same base. So what do you do to the powers? Add them. So this is going to be 4 to the 1/2 plus 3/2. So that's 4 to the 4/2. Shh. You have the same base, so what do you do with the powers? Add them. I gave you this. We've been working with this, and you did it nicely. A to the m times a to the n is a to the m plus n. You know that. That's what we've been using. So we have 4 to the 1/2 times 4 to the 3/2. So you add them together. 1/2 plus 3/2 is 4/2. What's 4/2? 2. What's 4 squared? 16. That's it. So this one right here, what do you do with that 2? Multiply it. So that's 2 to the 5/2 times what? What's 2 to the 5/2 times 2? 2 to the 10/2, which is 2 to the 5. What is 2 to the 5th? 32. Excellent. What about this right here? What do you do with that 1/2 power? You distribute it, so it's going to be 16 to the 1/2 times 4 to the. So that's the square root of 16 times the square root of 4. What's the square root of 16? 4. And what's the square root of 4? What's 4 times 2? Yeah. To the negative 1/2. What do you do with a negative power? It's going to be 1 over 25 to the 1/2. What does 1/2 power mean? Square root of 25. What is the square root of 25? 1/5. And then on the last one, do you have the same base? Yeah, you have the same base, so what can you do with the powers? So it's 3 to the 5/2 minus 1/2, which is 3 to the 4/2, which is 3, which is 9. 3 squared is 9. Here we go. So 27 over 8 to the 1/3. What do you do with that power? 27 to the 1/3 over 8 to the. So that's going to be the cube root of 27 over the cube root of, which is 3 over 2. 2 cubed is 8. 3 cubed is 27. What does the 5th root mean? What power? To the 1/5 power, yep. So what do you do with that 1/5 power? You 32 to the 1/5, x to the 15 over 5. What is 15 over 5? And what is to the 1/5 power mean? 5th root of 32, x times x to the 3rd. Because that's what 15 over. What times itself 5 times is 32? So this is 2 times x cubed. And last, and again, this notation is a little sloppy because that fraction kind of looks like times 1/2. But what is it? It's not times 1/2. What is it? It's to the what power? This means to the 1/2 power right there. The formatting is a little off. But what do you do with that 1/2 power? You 36 to the 1/2. M to the 4 times 1/2 and n to the 10 times 1/2. What does 1/2 power mean? Square root of 36. M to the what power? 2. N to the what power? 5th. And what's the square root of 36? 6m squared n to the 5th. There it is. There it is. Matt asked, like, how do you just know that, like, 32 is 2 to the 5th? It's from practice. It's like, you go back to before you really studied multiplication. What's 9 times 8? Did you know that when you first started looking at multiplication? No, you just know that 9 times 8 is. You don't really have to think about it anymore, right? So here's the deal. Let's talk about this. 1, 2, 3, 4, 5. So these are the numbers, and these are the powers right here. 1, 2, 3, 4, 5. Well, 1 to any power is what? 1. What's 2 to the first? 2, and then 4, and then 8, 16, 32. 3, 3, 9, 27, 81, 264. Sorry, 263, excuse me. No, wait, is that right? 243. What am I doing? Sorry. 4 to the first is 4, and then 16, 64, 256, and then it gets really big. 5, 25, 125, 625. It gets pretty big. You see these powers that I've laid out for you? It's big, right? Do you see these numbers? You're going to have to start recognizing these numbers because it'll really help you do your math. Like, so when you see 81, what is 81? 3 to the 4th. If you write it as 3 to the 4th, it makes things a little easier from the beginning. So, like, for example, let's go back to this one right here. You see 32, and what do you change 32 to? 2 to the? What is 32? 2 to the 5th. 2 to the 5th to the 1/5 is just 2. X to the 15th to the 1/5 is just x to the 3. So is it easier to simplify if you recognize your powers? Yeah, if you recognize your power. So for example, 36, what is 36? 6 squared. 27 is 3 cubed, and 8 is 2 cubed. Does it help to write them like that? Yes. Or does it really just help to recognize them? Yes. Yes, it will. Okay, so let's do this. So first of all, what is 42 over 6? 7. So we just took care of that. Let's do z's right here. Z to the 7th over z to the 5th. What's that? Make these z's. Z squared, exactly. So we took care of that. What are you left with? X to the 3/2 over x to the what? 4th. And you have 1 over y to the -3. I'm just separating it out. Do you have the same base right there? So what do you do with the exponents? So you have 7z squared x to the 3/2 minus 4. And what does this become? Where can you put that y to the -3? Put it on top, and if you put it on top, it becomes y to the 3rd. What's 3/2 minus 4? How many halves are in 4? 8. There are 8 halves in 4. So what's 3/2 minus 8/2? Negative 5/2 y to the 3rd. Now, is that the final answer? We don't like that answer because what? What's the one thing we don't like? Negative 5/2. So where do we put it? The bottom. So it's going to be 7 y to the 3rd z. Is that z squared, right? Sorry. Yeah, I didn't write it. Over what? X to the 5/2. Done. There's your final answer.